Hi.
My name is Tony Johnson. I work in Graphics, Siemens company. I'm not a Tcl' expert. I think this will be a different kind of presentation than any of the other ones I've seen. This is, I'm a user interface designer, do most of my work in C and C++. I've used Tcl'-TK for 20 years, especially Tcl'. The last 4 or 5 years I've been working on an application, happens to be in Qt for the graphical part, but we brought along the Tcl' interpreter in our product because it's the most powerful thing out there, and all of our electronic design automation tools use it. And it turns out to be incredibly powerful for the things that I need to do. Okay, so what's the motivation? Why did I write this paper? It was sort of kind of giving it to myself, in that giving it to the other me's around the world, and for you guys or engineers that you work with who are working in user interfaces, but they have some things they need to do to make their job easier and have a successful product. So, so the motivation, I want to explain why creating commands to control GUIs is important. Like, well, I got my GUI working, why do I need to have a command that does anything? I want to go explain a few reasons that you want to do that. I just kind of wanted to have just an example. This is very, I said practical. It's not prac TCL, but I use practical in the title of my paper. I just want to have an example out there, again, for those other me's around. It's like, well, I want to do this, but I have no idea how to do it. They can maybe look at this paper and go, oh, here's how one guy said he was successful doing it. I want to show some key constructs, just a few constructs in Tcl' that are particularly good choices for doing this type of thing, designing a command to control your GUI. And offer a few more key pieces of advice as part of doing that. Okay, so what was our motivation for wanting to have a command to control a piece of our GUI in the first place? I work in this window. It doesn't matter what this is. This could be whatever your application is. I do a lot of work in this window. There's an incredible amount of functionality there. So why do we want to have a Tcl' command to do that? Well, the first thing is our product actually has a Tcl' interpreter built in, so you'll see a little prompt down there. So customers can type in commands, you can run scripts, so Tcl' scripts, etc. And so we already have a Tcl' interpreter there, so we have ability to run Tcl' scripts, so why not? Because for testing is one of the reasons why you want to have a command. We've talked about some of the testing needs. You want to be able to, a way to have script control to be able to test your GUI, because you can't hire a bunch of people to manually test your product, every little code change you make. So testing's a big one. User control. Yeah, the users know how to use the GUI to get around your tool, but after a couple days of that, they want to have a script to do the manual labor things that they want to do. They want to have a command that does a bunch of things for them. Another key one, a key reason to think about this is once we had hopefully if you have a really successful product or a really successful sub-window of your overall company's product, everybody wants to use it. Everybody has their own, everybody as in other people in your corporation want to have their value added, and they want to grab onto and use and add to and manipulate your product because it's your feature, your window, because they have another technology that they want to leverage that. So that's the third-party access, that having a command to do this lets them in and lets them do certain things in a controlled way. They can't just jump into your source code, because that would be a huge nightmare. Save and restore. If you want to have your graphical user, your application up, and you want to like close it and reload it tomorrow, if you've got commands that control all these things, then that is an easy way to implement save and restore. And expandability was just the point that, as this evolves over time, you're adding more and more features. You want an easy, quick way to add more functionality in a way that still fits within all the other testing, user control, third-party access, save and restore, into that framework of being able to add things easily. So that's kind of the motivation. Super briefly, just wanted to this window, super complicated, lots of functionality. Same thing goes with your guys' applications. You can do all kinds of things, drag and drop, deleting, expanding, collapsing, adding things, creating grids, expressions. Just think of it as your application, but you can do a whole bunch of stuff. I would argue that this window is as complicated as it can be, and yet we can still make a Tcl command that allows you to control it, manipulate it, do all these things. And I'll show you an example of one at the end where it's very simple set of wave commands to control that. So, complicated GUI application. So, I know this is unreadable, but if we were going to make a command, a single command, that allowed you to do a bunch of these things, and we wanted to make it super simple, because remember, we have our testing people who, they don't know Tcl. We have users who maybe know just a little bit of Tcl, just simple little scripting thing. They don't understand including packages. They don't understand namespaces. So we want a super simple kind of wave, add, clear, wave, collapse, so a set of simple commands that are defined that can do everything you can do graphically from within your application. And again, this is super powerful for all those other parties, the testers, the third-party people, users. They need a very simple kind of interface to be able to do this graphical stuff. And it also gets to be, you can use it and save and restore. So that's kind of the end point of what the help for the command at the end. Now I want to go over how do we architect it. So I'm just going to go over just a few of the key routines that if whoever's reading this in the future, or one of you, like I said, you guys or your designers who are programming a GUI, what's the key pieces to be able to build this command? Where do you start? What do you do? Well, I'm going to go over the command registration. I happen to be going between Tcl and Qt, which has a different string representation, so I'll show a little bit of that. And in handling subcommands, I'll go over really the one key Tcl routine that is super powerful, and then some tips on designing the help in a way that I found to be useful. So I'm not going to go into super depth here, but the key routine for creating your command when you're whoever is implementing needs to create some command to control my GUI is the Tcl create obj command. And that's super simple, takes the interp, it takes the name of the command that you want to create. In this case, I'm creating wave, and then that will be, you'll be able to type that at your Tcl prompt, your Tcl shell, and where I want that to map to. I want it to map to this Tcl wave, which is my C function in our application's implementation. So pretty easy. You want to be able, as long as you've got a Tcl interp in your product, that's a whole nother discussion. I'm sure Brian Griffin could give a paper on or two. Map what you want to type in Tcl to the C function that you're actually implementing. String conversion, I just want to throw up a few things in here for posterity. In Qt, they have a thing called a CueString. I just wanted to show how you can go from Tcl to CueString. You can create a CueString, that's Qt's implementation, and just use Tcl getString on, as you're passing in objects, if you saw earlier, that the MyC Routine takes the client data, which we don't actually use, the interp, however many arguments are passed to that command, switches, and then Tcl obj array for the switches and their arguments that get passed in. So here, if I need to now get the CueString that I need to use in my C and C++ code, I just use Tcl getString to get that object string out, and I can feed it into my CueString. To go the other direction, Brian created this Tcl obj class that really is just, the main thing is it holds onto a Tcl obj inside of it. But you have a CueString, there's some conversion routines, and I actually used the wrong one, Brian corrected me, that you take the CueString and you do 2 local 8-bit const data, or what I should have used was this from UTF-8 to UTF-8 to get all the possible characters. But basically, I just get the CueString representation and have a method that takes that string and appends it onto a Tcl'. So a little bit of too much detail there.
What is the representation of a string in Qt? Is it
Unicode.
Yeah.
16-bit or
Yes.
UTF-16?
UCS4.
UCS4. Okay, and Tcl''s using UTF-8, right?
Yeah. I haven't run into any problems with using what I'm using up there, but we're really changing.
Yeah. It's no problem at all. It is
Sure.
ISO 859, which it's like a very small number of characters.
Yes.
It's a little bit of string conversion. Really, the key thing that I'm going to kind of transmit to all the other me's out there is this Tcl get index from obstruct. There's 2 routines. The first one is a Tcl get index from obj, and that's basically just when you've got all those subcommands you saw earlier, like wave and add and activate and all that stuff. The first one, Tcl index from obj, you basically have an array that's just got those subcommands, and that's pretty simple. When you call that, it returns you the index, as it's parsing the commands. That's a very simple way. Yeah, you can get your index, and now you know which command you're working on. But the really super powerful one is Tcl get index from obstruct. And that, instead of passing just an array of strings, which are the names of your subcommands, you can pass it a structure that has a lot more information in it. And this was the key thing for me in being able to get this designed in a way that's working really well. You can pass it like I said, a structure that, as it goes through and fine, as you're parsing your arguments to your command, wave, whatever. Yeah, sure, it'll give you the index of which command you're using, but you can also build this table that you can use and have other flags in it. Like those, all the commands, I build into the table an option description, which, if you remember back on that earlier when I said wave-help and you had that whole printing out of all the subcommands, all that's automatically generated from this table. Now, I've had to scrunch this table down a bit, but it's in my implementation. It's actually really long. It's got all of the descriptions that are used there, and my help is automatically generated from the table itself. So this does a few things. It, as new people, or myself a year from now, goes to add a new subcommand because we've added a new feature, I'll go to one place and I'll get into the right tense for my description. I'll not only call the command a reasonable thing, because I can see all the other commands in one table. I go, oh, mine is sort of like this when I do the description, in this way. Because so often when you, especially different people do different commands, they end up looking different when you do like a help. It's like, oh, this is obviously designed by 7 different people. If everything's in one table, it makes it much clearer and much easier to get it looking consistent. So that's being able to have, the description of each command in the table. You can also have, I created these flags that allow me to like mark that command as deprecated. That's what the DEP is. TPD is something I haven't implemented yet, but I want to, so I can go ahead and stick it in there. Hidden means it's a command that's just hidden that I want to make available to the third parties. We do this a lot with, like I mentioned, the other people in our company who want to leverage our tool. I can create for them hidden commands, because when I create it, I go ahead and I set the hidden flag in this structure. So everything having to do with the command is controlled from one structure, and it makes just things so much easier. A couple other points I made. I always remember command add, and I was like, oh, what's that command I'm looking for? Oh, I'll go look in the structure. And I do it in my IDE, I find the definition of command add, and boom, there's all the commands. Oh yeah, there was the one I was looking for. I forgot what his name was. So that's one little thing that makes it nice from a programmer's point of view. And I mentioned the options flags, and you can add as many other fields as you wanted. And the Tcl get index from obstruct kind of passes that along as it's parsing the command. So this was the real key. If you just remember anything from this, is that yeah, doing command to control your GUI is a good thing, and this Tcl get index from obstruct is a key routine to use to help you organize your command for your tool. So this is, I want to just show us a couple other little things on, this is that snippet of that main routine that is mapped from the Tcl wave command. It comes into here, get the interp, the objects. I call get index from obstruct. If I pass in a bad command, foobar, Tcl, it automatically takes care of going, oh, well, that command's not known. Here's the possible commands that are known. Here's an example of if help gets passed in, I can switch off of the index and then call individual help for those subcommands. I'll show you an example of that for this grid help message later. And then otherwise, I end up calling into my implementation code where I implement those features in our GUI for creating grids or adding markers or expanding or whatever. And I end up calling in to handle that command. I go ahead and continue to pass the interp and the object count and Tcl array down into the subcommands. Yeah, so it's kind of using the structure. It's super simple to use, but it gives you a lot. This was an example I just wanted to show on, you can't really read that, but that's a reminder of what the overall wave looked like. When you have a particular subcommand, like here I show the wave grid command. I did wave grid -help. That drops it down into the handler for that particular function. And I use the same kind of thing. I'll use, in this case, since it's super simple, the Tcl get index from obj instead of from struct obj. And then in the same way, and then switch off of what the command is. If it's wave grid help or wave grid clear in this case, I'll jump to the method that actually clears the grid. So it's kind of just showing a few examples of using both of those functions. And so just kind of to summarize, I just wanted, again, to get on to the other means out there that this is an example of why creating Tcl commands is important for all those reasons that I mentioned: testing, third parties, save and restore. Tcl is fantastic for allowing you to set up these commands in a way that makes it really useful and really easy to add new subcommands. The key routine, Tcl routines, and the real main one is a Tcl get index from obstruct. And the final note is that, designing it, keeping it such that, even if it's not you, it's your future self, or it's other engineers, doing it in a way that makes it look consistent to the user is really important. And even when that user might be your testing group, third parties in your company, the user themselves who don't know Tcl, they don't know the scripting language, but keeping it super simple is really important. And that's all I really had to say. Any questions?
In your table for the subcommands, if the user only types in a prefix, do you match it?
Absolutely. Oh yeah, thank you. And that automatically gets handled by the
And if they
method.
type in an ambiguous prefix, do you tell them what the possibilities are?
It will return the one that it matches. Or if it doesn't match, it'll tell you automatically which ones it does match. Unable to resolve, here's the two that it could be. And then you just got to type a couple more characters.
And that little shell that's in the lower
Yeah.
left, that's an interactive thing. People are typing into that.
Yeah.
Do you use command line completion on that? Or where you press the tab
yeah.
completion?
So our older product does, this one doesn't yet.
Yeah.
we've talked about it, but it's always been a door cut down.
Yeah, it's a-
Okay.
Another one of those features to work on. I was going to show, if I can here. Oh, no, I see. When I unplugged it, I lost my my demo. But anyway, that was pretty much it.
I was just gonna say, you know, that talk on how you implement the tab completion would be very interesting.
Sure.
I would love to hear that. Maybe nobody else will, but you can.
So anyway, thanks a lot.